Welcome to part 2 of our video series on trig substitution. Remember that trig substitution is a technique that helps us integrate functions involving square root of a squared minus x squared, square root of a squared plus x squared, or square root of x squared minus a squared. In our previous video, we looked at our first case where we had integrals involving square root of a squared minus x squared. And to calculate those integrals, we made the substitution x equals a times sine theta. In the process of computing the integral, we made use of the trig identity cosine squared theta plus sine squared theta equals 1. This identity helped us rewrite the problem without that troublesome square root. In this video, we'll look at the second case where we have an integral involving the square root of a squared plus x squared. For these integrals, we want to make the substitution x equals a times tangent of theta. Again, we'll be using a trig identity to help us deal with the square root. This time, we'll be using 1 plus tangent squared of theta is equal to secant squared of theta. Let's work through an example together. Let's look at the integral of 1 over square root of 25 plus x squared dx. For this integral, we can rewrite this as the integral of 1 over square root of 5 squared plus x squared dx. So according to what I have above, we want to make the substitution x equals 5 times tangent of theta. Taking the derivative of both sides, we have dx equals 5 times secant squared of theta d theta. So making our substitution here, we get the integral of 1 over square root of 5 squared plus 5 tangent theta squared, and the dx gets replaced with 5 secant squared theta d theta. Now let's simplify what's inside the square root here. If I squared the 5 tan theta and factor the 25 out, I end up with the integral of 1 over square root of 25 times 1 plus tangent of theta squared times 5 secant squared theta d theta. This is where I'm going to use my trig identity. I can rewrite the 1 plus tan theta squared with secant squared theta. So this gives me the integral of 1 over square root of 25 secant squared theta times 5 secant squared theta d theta. Well, what we notice here is that everything under my square root is a square. So I can simplify this as integral of 1 over 5 secant theta and then times 5 secant squared theta d theta. This reduces to the integral of secant theta d theta. Although it's not immediately obvious what the antiderivative of secant theta is, this is something that we can compute. The trick here is to multiply the top and the bottom here by secant theta plus tangent theta. When we multiply the top and the bottom by the same thing, we're essentially not changing anything at all. When we multiply this out, we end up with secant squared theta plus secant theta tan theta in the numerator and secant theta plus tan theta in the denominator. What we're going to do now is make a substitution. We're going to let u equal secant theta plus tan theta. When we take the derivative to get du, we see that we get secant theta tan theta plus secant squared theta and then d theta. So that's exactly what we see in the numerator. So making this substitution, our integral becomes integral of 1 over u du, which we know how to integrate. This is ln of absolute value of u plus c. Now, rewriting this in terms of thetas, this is ln of absolute value of secant theta plus tangent theta plus c. And our very last step is to rewrite this back in terms of x. we had our initial substitution of x equals 5 times tangent theta. So if I solve for theta, I get x over 5 is equal to tan theta. This means that theta is equal to arctan of x over 5. So if we substitute this into our antiderivative, we have ln of secant of arctan of x over 5 plus tangent of arctan of x over 5 plus c. This expression here can be simplified a little bit. For example, the tangent and the arctan will cancel each other out. And we can also simplify the secant of arctan of x over 5. So again, what we're going to do is imagine a triangle. Arctan of x over 5 refers to some angle in that triangle. Remember, from trigonometry, we know that the tangent of an angle in a right triangle is equal to the opposite over the adjacent. So if I have a right triangle with sides x and 5, then the arctan of x over 5 would be this angle right here. Now the secant of that angle would be the hypotenuse divided by the adjacent side. According to the Pythagorean theorem, I know that the hypotenuse has length 5 squared plus x squared. So the secant of that angle would be square root of 5 squared plus x squared divided by 5. So in the end, our antiderivative is ln of absolute value of square root of 5 squared plus x squared divided by 5 plus x over 5 plus c. And that's our final answer. That's it for this video. In our next video, we'll look at the very last case where our integral involves the square root of x squared minus a squared.